Hey, welcome back to the course. In this lecture, let's cover the last lecture of this section, that is understanding multitasking. Let me first give you an analogy of multitasking. Let's consider your typical day. You have got 24 hours and you try to accomplish various tasks. So like eating your breakfast, replying to your emails, taking the phone call, taking notes, attending appointments, sleeping, etc. So your day consists of various tasks and you try to accomplish as much as possible to keep your day more productive. So how do you accomplish all these tasks? So one way is you will give a time slice for each activity, right? Let's say 20 minutes of time slice for eating your breakfast, 20 minutes for writing emails, etc. And the other way is you can offload the work to your assistants to increase your productivity, right? Similarly, in multitaskable computing, an application may consist of multiple tasks. Each task is supposed to carry out one unique functionality. So let's say there is an application called temperature monitoring system, and this application has got 3 unique tasks. Task 1 does sensor data reading, task 2 updates the display, and let's say task 3 processes the user inputs like button press, etc. So this application implements multiple tasks, isn't it? A task means just think like a piece of code which can run on CPU and execute. So now you have got one CPU and you have to run all these tasks. So how do you run it? One way is give a small time slice for each task to run. Let's say after time slice 1, remove the task 1 and make task 2 to run, and so on. So to do this, you need a scheduler. A scheduler is one who takes care of scheduling all these tasks onto the CPU to execute. So in a multitasking scenario, a scheduler also plays an important role. Now, another way to run all these tasks is to use a multi-core processor. Let's say you have a processor with 4 cores. In this case, you don't need a scheduler to run this application, isn't it? Why? Because it has got 4 cores and each core can execute one task. So all these 3 tasks can execute simultaneously. But in embedded world, we don't usually use a processor which has got multiple cores. We usually will have one core and multiple task scenario. So to run all these tasks, you will need a scheduler, and scheduler will decide which task should take the CPU next. So this is how multiple tasks execute on the CPU, which gives the illusion for you that all the tasks are executing simultaneously. For example, in your desktop, you typically work with lots of softwares simultaneously, isn't it? Like you browse the internet, you listen to music, you edit your code using editor application, you use calculators, etc. So all these applications will have the respective tasks or processes which share the CPU. But your OS is designed such a way that it gives you the feeling that all the applications are running simultaneously. Great. So that was a quick introduction to multitasking, and we are at the end of this section. So I will see you in the next section. Thanks for watching.